Fluids are all around us, and each one flows in a slightly different way. Some are chaotic, and some are more smooth and regular. Today we're going to talk about how to determine different fluids' properties, and we do that with the Reynolds number. The Reynolds number is the fluid density, ρ, times the fluid velocity, v, times the fluid diameter, d, divided by the fluid viscosity, mu. It's also known as the ratio of the inertial forces to the viscous forces in the fluid. Large Reynolds numbers lead to turbulent flow, and small Reynolds numbers lead to laminar flow. Turbulent flow is chaotic and has lots of mixing, like in a smokestack. If we look at the Reynolds number for a smokestack, we can see that the viscosity is really small and the diameter, d, is really large, which is why we have turbulent flow. Laminar flow is the opposite of turbulent flow. It's very smooth and regular, like when honey flows. Every molecule has its place. If we look at the Reynolds number for honey, the viscosity is very high and the velocity is very low, which leads to a low Reynolds number and laminar flow. Our final example is lab-on-a-chip devices. They have really tiny channels with diameters smaller than a human hair. Because these diameters are so small, we can get fluids that are really fast and still have a Reynolds number small enough for laminar flow. In fact, the fluids can be faster than supersonic velocity, which is faster than the speed of sound. So to recap, there are two different types of flow: laminar, which is smooth and ordered, and turbulent, which is chaotic. And it's the Reynolds number that helps us determine which flows are laminar and which are turbulent.